This video is an introduction to dividing polynomials using long division and synthetic division. The section is 2.3, and you should put this at the top of your notes as the section heading. Before I show you how to do long division of polynomials, it's a good idea to review how to do long division, period. So to divide 4,619,532 by 7, I start by saying how many times would 7 go into 46, or 7 times what would be 46? Well, 6 is as close as we can get, and then I would do 6 times 7 is 42, and write that right underneath, and then I subtract. 46 minus 2 is 4, and I would bring down the 1. You might think this is silly, but you're going to have to really have a good understanding of this process in order to get how to do long division. And so then I repeat the process. 7 goes into 41. How many times evenly? That would be 5, which gives me 35. Again, I subtract, which is 6, and bring down the next number, which is 9. 7 goes into 69 9 times. 9 times 7 is 63. Subtract, and you get 6. Bring down the 5. 7 goes into 65 also 9 times evenly for 63. We get 2 when we subtract, bring down the 3. Oops. 7 goes into 23 3 times, which is 21. I subtract, which is 2. Bring down the last number, which is 2. 7 goes into 22 3 times again, with 1/7 left over. So the answer would be 659,933 and 1/7. It's also worth noting that this, my answer, which is called the quotient, times my divisor, what I divided by, would get me back to my original. That's going to be important moving forward. All right, let's do an example involving polynomials. In this example, I purposely chose to divide this quadratic by a linear factor because we don't actually need to use long division to do this. I could factor this polynomial. This is one of the factors, and there's another linear factor. And those two factors, if I were to multiply them together, would get me this. So here I'm trying to demonstrate that dividing polynomials can often give you additional factors of that polynomial. Okay, to start, it's easier to ask yourself, x times what gives me x squared? Well, that answer is x. So I write that down, and just like we did before, I'm now going to multiply this times my linear factor. So x times x minus 2 is x squared minus 2x. And just like we did with the other example, we're now going to subtract. X squared minus x squared is 0, and 4x minus negative 2x is 6x. As we did before, we will now bring down the next term, which is minus 12. And again, we ask ourselves, x times what would give me 6x? Well, plus 6. And so 6 times x is 6x, and 6 times negative 2 is negative 12. And you'll see we do not have a remainder. The remainder is 0. What that means is that this is another factor of our dividend, our original. And as I reminded you with the previous example, this factor times this factor would give us our original dividend. In other words, x minus 2 times the quantity x plus 6 equals this. Before I do another example, let me clear up some vocabulary. This is what I was saying on the previous example, but you might want to take a minute to write this down, and on the next slide I explain the vocabulary. So I recommend pausing the video to write this down. I've taken this slide from your book. I just took a picture, but I like that it is showing visually that what you're dividing by is called the divisor. The answer that you get when you do division is called the quotient, and the thing you're dividing is the dividend. If there's a number besides 0 left over, that's called a remainder. And so we can see that when you divide x squared plus 3x plus 5 by x plus 1, you get a factor of x plus 2 with a remainder of 3, which means this is not one of the factors of the polynomial. It's not going to end up being a 0 of the graph. And so you can see it written differently here. If I divide this, I end up with x plus 2, that's my quotient, plus 3 over the divisor, x plus 1. If you remember in my first example, when I divided by 7, I had a remainder of 1, and my answer in the end had a 1/7. So it's the same exact idea. If you need to, take a moment to pause the video to put this into your notes. I chose this example because it's missing the quadratic term, and I wanted to show you how to handle that. Notice I filled in a 0x squared term into my dividend. This will help me stay aligned as I do the long division. First thing we should ask ourselves is x times what is 5x to the third? That would be 5x squared. And then I do the multiplication. 5x squared times x plus 2 would be 5x cubed plus 10x squared. As always, I subtract, and 0 minus 10x squared is negative 10x squared, and I bring down the next term, which is 6x. Repeat the process. So x times what is negative 10x squared? Negative 10x. And now I multiply negative 10x by x plus 2, and I get negative 10x squared minus 20x. Again, I subtract. Be careful when you're subtracting. 6 minus negative 20x is actually plus, so I get 26x. I bring down the last term, which is 8. And last time I say x goes into 26x, or x times what is 26x, and the answer is 26. And when I do the multiplication, I get 26x plus 52. And when I subtract, I'm obviously going to have a remainder of negative 44. Now, something that's very cool about this is that if I were to set this equal to 0, so when x is negative 2, when x equals negative 2, that's not a 0 of the function, because this is not a perfect factor because I had a remainder. But what's really cool is when x is negative 2, the y value of this cubic would be negative 44. So the point negative 2, negative 44 is on this cubic graph, 5x cubed plus 6x plus 8. So since I was asked to divide here, my answer would be 5x squared minus 10x plus 26, that's my quotient, and then I had a remainder of negative 44, which I could write as minus 44 over x plus 2, which is the divisor. So technically, this is my answer. Okay, part 2 of this video is using synthetic division. This is kind of a shorthand to long division. The idea is the same, but it actually looks like the opposite, which should become clear once you see an example. Maybe take a moment to write down step 1 and this example. So when using synthetic division, we only write down the coefficients of each term in our polynomial. And as I've written up here, if any term is missing, you use 0 as a placeholder, just like I did in long division, and the dividend must be in standard form. If it's not, you will not get the correct answer. So on the next slide, I have the coefficients for each of our terms here, and I have reversed the sign of the divisor. So here are my coefficients. Here is my divisor. You'll notice the factor was x plus 3, and so I've written negative 3. And then step 2 is to just bring down this first coefficient, whatever it is. It doesn't have to be a 1. So the first step is to rewrite this, and then you multiply each of these by the divisor, and then you add. The reason that it's the opposite process from long division is that I've made this number the opposite. So let me go through this example. I've written down my first coefficient, and I do negative 3 times 1, which is negative 3. I write that here, and then I add. 6 plus negative 3 is 3. I now repeat the process. Negative 3 times 3 is negative 9. I write that down, and again I add. 5 plus negative 9 is negative 4. I repeat the process. Negative 3 times negative 4 is 12. And when I add, I get 0. So this means there is no remainder. You're probably wondering where our answer is, or how this is the answer. Well, if you remember, these were the coefficients for our cubic function. And so these are the coefficients of my answer. Since I divided this cubic by a linear factor, it's now been knocked down to a quadratic. So these are the coefficients for a quadratic, which means that it's 1x squared. For effect, I'll put in the 1, plus 3x minus 4. And since there's no remainder, what that means is that x plus 3 is a linear factor of this cubic. So I have actually now factored this cubic to be x plus 3 times the quadratic factor x squared plus 3x minus 4. And where we're headed with all of this, very exciting, is that I could then further factor this into its two linear factors, which would be x plus 4 and x minus 1. And now I have the three linear factors for this cubic. Before today, we could not have factored easily this cubic. And now we have a process to do that. So I could now ask you to graph the cubic y equals x cubed plus 6x squared plus 5x minus 12. And you would use either long division or synthetic division to divide by a factor. And after that, you can factor the quadratic that remains into its two linear factors. And so here are the three factors, which would lead us to our three x-intercepts or zeros of this cubic function. Here I have in written form step 3 of the process of synthetic division, if you want to take a moment to write this down. Pause the video. And here in written form is step 4, where I explain that the resulting numbers you get are the coefficients of your answer. I know this is a long video, and I'm sorry for that, but I wanted to show you one more example where I'm missing some of my inner terms. So I'm going to need to put zeros in as placeholders. Okay, I've written the coefficients of my cubic right here, and here's my divisor. You'll notice it's the opposite of the linear factor that I see. And if you remember, the first step is to just bring down this first coefficient. And now I'm going to do 3 times each of these numbers down here and then add. So 3 times 1 is 3. And when I add, I get 3. 3 times 3 is 9. And when I add, I get 9. 3 times 9 is 27. And when I add, I get 0. So here's another example where we have no remainder, which means that this is a factor of this cubic. My answer, since I was asked to divide, is now x squared plus 3x plus 9. But if I were trying to factor x cubed minus 27, then I would say it's this quadratic times the linear factor that was my divisor. Sadly, this does not factor further, so we do not have 3 linear factors for this. We have 1. Now it's your turn. I'd like you to copy this example into your notes twice. Once, I would like you to use long division, and the second time use synthetic division. Your answers should match. Thanks for watching this video. I hope it was helpful.